Okay, today we are going to go through the electron energy levels, and we're going to connect the electron energy levels with the real world application, including fireworks and the elements in the stars in the universe. Okay, first of all, I need you to write this information in your notebook. One thing is the electrons are orbiting around the nucleus in certain energy levels. We call those circles electron energy levels, which is where the electrons are moving around. Also, sometimes people call those shells. Electrons can move from one orbit to another by absorbing or emitting energy. It means, for example, originally this electron is moving around this circle. Once we give it energy, it can jump to a higher energy level. Okay, we give them different names. This part I also need you to write it down. One word is called ground state. The ground state is the lowest possible energy level for an electron to stay at. The most close to the nucleus. It's the most stable. It's just like when we stay on the ground, it's the most stable for us. So when the electrons are in the ground state, it's the most stable for the electrons. And also, if we give energy to the electrons can absorb energy and can jump to a higher energy state. We call it excited state. In the excited state, it's not stable. Okay, it's because the energy is higher, but it's not stable. What's gonna happen is the electron would automatically jump back from the excited state to the ground state. So to summarize it, electrons absorb energy, means receive energy, and they can jump from the ground state to excited state. But it won't stay in the excited state. It will automatically come back to a lower energy level. Just like when we jump into the air, we won't stay in there. We will come back automatically. That's the same thing would happen for the electrons. I'm going to use this Bohr model of atom. It's a quick simulation. I'll help you to understand it better. Okay. Here is a typical atom. This is the nucleus, including protons and neutrons. And this blue color one is an electron. There is only one electron. Right now, this electron is moving around the nucleus in the lowest energy level. We call this the ground energy level. And we are going to give it some energy by click this. Okay, and once they absorb energy, this you can observe it again. This green color one represent some type of energy as well. We just learned today. The light is a type of energy. It absorb energy, it will receive the energy, go to a higher state. We call those circles the excited state for this electron. Okay, this electron it won't stay in here because it's not stable. It will automatically go back. Okay, so let's observe it one more time. Give it energy going up, and when it come down, you can see there is a spark. Okay, here's a spark. This spark means it release energy, gave off energy. Okay, so now let's continue. And how do we call this spark? The spark it gave off is a kind of a light energy. People call it photons. You may write this down, just some information for you. Photons are a type of energy. What kind of energy is the light energy? It's mainly talking about the visible lights that we can see. This kind of energy can be released when the electrons jump back from a higher energy level to a lower energy level. Okay, so one thing we want to talk about is for different elements, like there are totally 118 type of elements in the periodic table, right? For different elements, they have different electron energy levels. The electron energy levels for each element is very unique. It's just as unique as your fingerprints. Like everyone in the world has a unique fingerprints. Every element in the world have their unique electron energy levels. Because they have very unique electron energy levels, when they jump from the excited state to back to the ground state, they would release different amount of energy. As what we just talked about today, when the different amount of energy would relate to different colors. It can be red, green, yellow, or blue, purple, it can be different colors. Okay, so that's why in the fireworks, that's actually the fireworks contain different kinds of chemicals. And then when we heat it up, when we burn the firework, we give it energy. When we give it energy, the electrons in those elements would go from the ground state to the excited state, but it won't stay in there. It will come back down to the ground state. Once it come down, it's just like instantly happens. Okay, once it come down, it will show up as colors, and different element would show up as different colors. Okay, we are going to do a flame test demonstration during the live class tomorrow. Okay, hopefully you are going to enjoy those beautiful colors. Okay, the other application for this is to identify the elements in the stars. Okay, so the scientists can use the equipment to detect the lights emitted from the stars and to generate a unique emission spectrum to figure out what kind of element are in those stars. Like different element, sodium has this kind of spectrum, hydrogen has this, calcium has this. When they match up with those spectrum, the scientists can figure out what kind of elements are in those stars. Okay, so to summarize, what you have learned today is the electron energy levels, and uh, electrons can jump from ground state to excited state, a higher energy level, and also come back to release some energy. It can show up as colors, and different elements have their own unique electron energy levels, so they can release different amount of energy. Those different amount of energy can show up as different colors. That's why we saw beautiful colors in the fireworks, because they're different elements. Okay, hopefully, please watch the other firework videos, and then tomorrow we are going to do a lab demonstration. Okay, thank